Assalamu alaikum, dear students. Welcome to the course of Materials and Manufacturing Processes. Today, our topic of discussion is product design considerations. Before this, you have covered what is casting, how to design mold, the different materials of mold, the different types of castings, what are the defects that occur in casting processes, and the different materials that can be used as a casting material. So if you have or the designer have decided that casting is the main process to produce that product, then there are some certain guidelines to follow, and these guidelines can be called as product design considerations. So the first thing is the geometric simplicity. Geometric simplicity refers to the is simple the product will be, the easily the casting can be performed. So our main goal is to simplify the casting itself. So it does not mean that with casting we cannot cast much complex design products. But if the product design is simple, the casting will be easy. Okay, so it helps in castability, so the casting will be made easy. Okay, it also helps in designing mold for the casting. And finally, it also has benefit for the strength of the casting. Strength of the casting will increase. So the less number of surfaces, the less number of edges, corners, etc., we will have a more good product to cast. Then we have the issue of corners and edges. So if there are corners and edges, it must be filleted such that you can see here that these edges are blended, or in these the internal edges are filleted. Okay, so what is the issue actually? If there are more edges or corners, sharp edges, I'm talking about sharp edges, then due to hard tearings or cracks, which is one type of defects in casting. So due to hard tearings, there will be much more stresses on the edges and corners, and due to this, it can crack. Okay, so sharp edges, sharp edges or corners must be avoided, okay, because uh, can be subjected to more stresses due to hard tearing, okay, which is one form of defect in sand casting. And finally, edges must be filled or blended in such cases. Okay, So if this is for the expandable mold casting, then we have to fillet or blend the edges of the pattern. Okay, and permanent mold casting, the mold cavity must encounter these considerations. Then we have section thickness. Section thickness refers to, for example, if you have a casting where there is a kind of pipe going on where the diameter it start is more and diameter the end is smaller. So the issue will be that there is more metal at the bigger diameter, okay, and the small metal here is at the smaller diameter point. So the issue will be that this part will solidify quickly, and this one will solidify a little bit later because there is more metal, and it will take more time. So due to this reason, the shrinkage occurs. So this phenomena is called the hard tearing. Okay, sorry, it is hard shot. Hard shot. Hard shot is the defect in the casting when there is asymmetric thickness between the cavity. Okay, so let me define it here that uh, thickness in the casting cavity should be same. If not, then issue of hard shot arises where the metal is small thickness will solidify quickly, and metal uh, bigger thickness sections will solidify later, causing shrinkage in the cavity. Okay, or shrinkage in the casting. So it can be avoided by making some small changes in the casting itself. For example, you can see here in figure 11.24 in part A, here is the original casting where thickness at this point is much bigger than those sides. So the shrinkage occurs here, and we can call it is the shrinkage cavity, which can be seen here in the center. So one solution to avoid this is to decrease the thickness of this section, okay? Or we can design another core or internal surfaces into this sections. So if the design allows for such kind of changes, so here it is the one solution for addressing this issue. Another solution is to employ some cooling mechanism in this part. Now coming towards the draft, very important and special. And let me define these two properties together. So draft and core. So for example, if the mold, here you can see the mold or the cavity, if it is projected into the mold, so we usually apply some extra angle or draft into the mold cavity. And it is because of if we are thinking in respect of the expandable mold casting, so it will provide ease of taking out the pattern. Okay, so in expandable mold casting, draft provides to um, easily take out the pattern from the mold. While in permanent mold casting, draft provides to take out the part easily from the mold. Okay, so mainly you can see here from the figure that here is the core, okay, and here is the cavity, and here you can see the draft. So due to draft, we can easily take out this pattern from the sand mold, or from permanent and permanent mold, the part can be easily taken out. Another issue in or the another consideration which must be addressed is use of core. So the less number of cores, the easily casting can be performed. Okay, so we need to avoid cores because it takes time, it takes expertise. So if it is possible, we need to avoid use of cores. Okay, so here you can see that this is a core which is being made in this internal part of this cavity. So if we can avoid these parts, okay, here you can see these two internal sides. So the next figure, you can see that these are avoided, and now there is no need of to design any core in this casting. Dimensional tolerance, very important. It is something subjected to the types of casting. For example, if you are casting some particular product in different casting types, such as we have covered the expandable mode castings and permanent mode castings, and further there are subcategories of that. So every casting itself will provide different dimensional accuracy. Okay, so we need to encounter these accuracies or these tolerances in our design. Okay, so for example, here in the figure you can see that if we are casting performing casting process like sand casting, so for different materials we get different tolerances levels. Okay, so for aluminium, the tolerances are from 0.020 an inch or plus 0.5 in millimeters. For cast iron, if it is small, these are a small product, so 1.0, and for large dimensions such as length or width or some other geometric attributes. Okay, so for copper, steel, and so you can go through the list. And for permanent mode, the values will differ. For aluminium, it is plus 0.25, and for cast iron, it is plus minus 0.8. Okay, so these tolerances must be measured, and they must be properly encountered in the design of the casting itself. Finally, surface finish. Surface finish is something important because in more sand mold casting, the surface finish is around uh, 1.6 micrometer. First, okay, let me confirm it. Sorry, for chain casting, the surface finish is around 6 micrometer. Okay, so surface finish is in chain casting. In chain casting, surface finish is around 6 micrometer, while in die casting, the surface finish is around 1 micrometer. Okay. So it always depends on the what is the metallurgical properties of casting, such as in sand casting. If the grain size is bigger, how they are blended with each other. Okay, so it defines what will be the surface finish of the casting itself. In permanent mold process, it has quite better result because there is permanent mold made of metal and there is lubrication involved, so the surface finish is relatively better. Finally, coming towards the machining allowances, as we know that when we get the final casting, it cannot be used as a final product. So some certain types of machinings must be performed to trim the extra surfaces or to increase the finishing of the material. So there must be some considerations for the machining allowances, such as some extra material must be added with the or original dimensions. So machining allowances, or it is more important in sand casting. Machining allowance is more important in sand casting because we have to add more extra material. This final product from sand casting cannot be directly used as a final product in most cases. So you need to remove the extra stuff and mm, uh, finish the surface of the casting itself. So for this reason, we have to add some extra, allow for some adding some extra material. So it is done. Let me summarize it again. Uh, for casting any product, we need to follow some guidelines, which includes the geometric simplicity. The more simple is the product, the more better. The less number of corners or the more smooth corners there are, the better casting will be. If the corners are sharp, and it will cause a lot of stresses due to hard tearings, and the casting can be cracked. uh, then we have the section thickness. So the section thickness must be kept same or constant, because if there is some difference in thickness, it will the issue of hard short will arise. Okay. And finally, the draft is actually used for removing the pattern or the part from the mold itself. Use of core, it must be avoided. The less number of cores, the better casting will be. Dimensional tolerances, we need to look for individual or different types of castings. So in sand casting, we will look for some different dimensional accuracies, or and for permanent mold casting, we will look for some other dimensional accuracies. So we need to encounter there for different, also for the different type of materials. And finally, the surface finish. So in sand casting, the surface finish is around 6 micrometer, and for other processes like die casting, the it is around 1 micrometer. While we have another types like investment castings, shell castings, so the surface quality is quite better in those casting process, then the sand casting. Machining allowance, it allows for any extra material that is added to the original dimensions. So we can machine the product finally and it can be used as a final product. Okay, so that's all for today. Okay, thank you.